PaLM for text. And I'm going to show you a demo of that. PaLM for text is a large language model that's been trained to interact via text. You can ask it questions. Actually, even though we say text, you can do it via voice as well. We'll still transcribe that to text and you can respond. But anyone here played with Google Bard? Okay, anyone here played with ChatGPT? Yeah, I figured there's some people. The point is that experience is available to you here. So we have a model that does that. We have a model specific for chat. So text is great for, one question. I'll tell you, I'm back in school. I use this for all of my homework. Don't tell my professors. I have some data analysis thing. He thinks I'm really smart, essentially. So you have all of these questions. PaLM for text is great. If you want to have an actual conversation, I can do stuff like say, hey, you're a call center agent for the Department of Environment. Look on the website and answer any questions about it. And now it will have this multi-turn conversation where it's maintaining the context for you. And that's all you have to do. Let's imagine, I'm going to show you a demo of Imagine. Imagine is our text to image. We can use it for image generation, image classification. So think about creating content for your website. So just, we built this actually into Google Slides. You want to figure out some images for your slides. The point is I can essentially write a prompt, and I'm going to show you a quick prompt, and it will generate the images. Just a ton of capabilities. We can upload images, we can select styles, so particular styles as well. So say you have a particular style for your department, you want to be able to mimic whenever you create content for the department, we're able to do that as well. There's also embeddings API for text and images. Think about this as Google bringing our search capabilities to all of your content. So we'll create embeddings in the vector space, not to get into it. Figure this, the way I typically explain this is we can help you use your content to provide Google type search, a Google type search experience for your constituents. There's also Chirp for speech to text. This is a universal language model. In the past, we trained language models one language at a time. Remember I mentioned this about neural networks. When you train those models, they were task specific. I can identify cats, but if you give me a picture of a pigeon, I have no idea. The same way, we had models that understood English, a separate model understood Spanish, a separate model understood German. Now we have this universal language model that is able to understand just about every single language, and it continues to grow, of course. So now, unlike in the past, when you'd say to me, hey, I'm a multilingual, and what do I need to do to curate content about multilingual, I have to have English content and Spanish content. On the back end of this, as we start to integrate it into Dialogflow, you'll see the ability for your virtual agent to just understand whatever the user's language is and respond to them as well. We also have coding for code generation for the developers here. Coding is one thing I've avoided since I left college. But the fact is now I can code like a pro, essentially. Because now I can have regular language prompts and say, write me a code to upload a file to Google Cloud Storage Bucket. You can use coding to debug code. You can just put comments in code. All of this is available. So these are tools where, in fact, some folk in organizations will upload the entire corpus of, essentially, their whole code database, and now it will write code that is similar to the code that you've written because you've taught it how to do that. Again, I have to emphasize here that whenever you provide information or data to Google Cloud, we don't have access to that information. Your data stays yours. I'm going to spend a bit of time talking about that later on. How much time do I have? I'm sure I'm over, but how much time do I have to round over that?
How much more do you need?
10 minutes. Is 10 minutes.
Okay, so
everyone good for 10 minutes?
Okay.
I'm sorry. I know it's a ton of content, but I'll be done soon. The Model Garden gives you access to all of Google's models, our first-party models, but also third-party models. So you might want to go use, for some reason, whatever it is, Anthropic's Cloud or something. You might want to go use Meta's Llama. The point is, Google is dedicated to enabling the open source community. So yes, we do believe our models will give you the best value, but you might say, hey, I want to use somebody else's model. We'll allow you access those models in an environment with all of our MLOps capabilities around it. So in certain instances, many instances, it's more secure to use third-party models in the Google Cloud environment than in the environment for folk who develop them. Because if you think of if you think of a lot of the folk who are building models today, or some of them, they don't have the same expertise as Google has, securing billions and billions of users' data, right? So you can actually use third-party models in addition to Google's first-party models, inverted AI model guarding. Generative AI Studio is all of our tools around building, deploying, managing models. Essentially, think of this as an environment where you can go take your data. If you said, hey, Google has all of these models, but I want to build my own model. I don't want to use the models Google provided. We allow you to take your own data, train your models, provide you the tools, deploy the models, and we'll provide you an API endpoint. So now, this is completely end-to-end. I can't imagine why you would want to do it, but if you chose to do it, all of the tools are available to you in Gen AI Studio. Gen AI Studio will also allow you to use our existing large language models and any of our, essentially any of our models that already exist. I'm speeding through this. I'm really sorry. I'm down to 10 minutes. I have a few more demos to show. When you can tune, you can make use of our extensions. Again, I talked about extensions earlier on. And you can actually do grounding here. We'll actually have knobs to tweak. Some examples of this are top P and top K and temperature, where you'll be able to say, hey, here's the length of response I want my model to give by default. You'll be able to say, here's the confidence I want the model to have. If your use case is writing email, you might be fine with the model, being verbose and using its imagination. But if your use case is, I don't know, writing a technical document or something, then I want this, I don't need you to be verbose here. I want you to be very brief and very specific. We'll give you those knobs to tweak, essentially, so you can build solutions that meet your requirements. Okay, so let's jump into a bunch of demos, and then I have only a couple more slides, and then I'll run this off. So let's start off with a text demo. And what I've done here is, what I'm showing here is actually it's Google's Gen AI Studio that I just talked about. So here, I'm going to pick a text model and say, I'm going to write a text prompt is what I should say. What I will do is I have a bunch of prompts that I've already created in the past. So let these come up. Can everybody see here? And so I will start off by summarizing an RFP. So I copied off the text for an RFP. Let's see this come up. I don't know if everyone can see this. Is this big enough for everyone? So summarize, and in fact, I said the follow, I should type the following. Summarize the following RFP. And you see here the information, the text of the RFP, and I'll click submit. And you can see here what the summary is. Right? So bring this up. It says the Oklahoma State Public Defender's Office is seeking proposals for a new blah, blah, blah. This is fine. I'll summarize the RFP for you. But you know what? I don't even need to provide the text, right? Let me do this. Save the updates. I don't need to write. I can point this to the website. So for example, I'm going to summarize this online document here. And can you see what I've written here? Summarize, and I've simply given it a URL here, right? So we're able to go out and summarize the information that is at the URL I've provided. Let's see how we do. Again, you can see the summary here, just based on the URL that I provided. So think about the applications for your, essentially for your environment. One of the things that typically happens is people will have meetings, council meetings, whatever the case may be, and they have all of these videos, or they have all of this text, and who wants to go listen to like 3 or 4 hours of folks speaking, essentially. If I get this into a particular format, I can simply point to it and say, summarize the meeting for me, or whatever the case may be. Or like I said, my thing right now is summarize this new tax law, or summarize this policy, or something of the sort. Which is why when I have these conversations with my friends, and I told me, you've suddenly become really smart in the last 6 months. I'm like, yeah, because this is exactly what I'm doing in the background. The point is you get all of this capability. Let's go take a look at Imagine. So for Imagine, I talked about the fact that say you're creating content for your website, or just content for documents, whatever the case may be. Now I have an actual prompt, I think. Let me see if I have a prompt here that will work for me. 1 second. I think I copied the prompt. And again, all of this is, 1 second. Let's use this prompt. So I'll show you the exact prompt I typed. And what I'm saying here is, essentially I'm asking it, create an image for me of a ship at sea and it's storm, is what I'm saying here. Let's see how well we do. And let me go to the beginning, make sure that a second. Can everyone see this? I've said hyper-realistic photo of a ship at sea in the midst of a storm. The ship is battered by 50-foot waves. Essentially, I'm just describing what I want. Let's see what it comes up with. That's not the image. So, what do you do? So I might need this for content or something of the sort. There's also just a bunch of other capabilities here. You see here, we have the ability to say, what don't I want to see? So that's something else we can do. How many results do I want? I've chosen 4. If you have I might say, hey, I want this to be in a specific style. I'm able to do that. I can also upload documents or video and tell it to provide me a description, right? So again, think about, I keep on using those council meetings. I can upload those, give me a description, tell. All of those I'm able to do here. I'm going to start rounding up because I'm way over time now. But I typically will end here because this is one of Google's differentiators. Just how we bring these solutions to the enterprise, right? For us at Google, enterprise readiness is a critical part of our approach to generative AI. So first of all, we always build into every solution the ability to manage your data. And I think someone had mentioned, what happens to my data? Does it become Google's? That never happens. Security and compliance is identical to what folk get when they use any of those 9 products I talked about that have over 1 billion daily users, right? So think about the fact that the same way that we secure Gmail, we secure Android, we secure search, we secure Drive, we bring those same capabilities to the solutions that you will be deploying in your environment. Everything we do, we have reliability and sustainability built into it. Google is one of the most efficient companies on the planet. Our data centers essentially run green. We are very focused on making sure that when it comes to reducing carbon emission, reducing the amount of trees that folk have to cut down, every time you use a Google solution, you want to know that the organization you're working with takes that very seriously. And we also believe in responsible AI. I'll talk about what responsible AI is. Now, again, to emphasize to your point and for everyone here, we ensure that when we use AI, we never use your data to train our models. In some instances, you will get asked, would you like to provide us your data training model? And if you choose to give us permission, then that's the only circumstance in which we will use your data. You benefit from all of our expertise, and I talked about this just around privacy. GDPR, for example, again, not in the US, that's a European compliance requirement. But if you build solutions essentially that you say you have users, I've worked with some agencies where the constituents are spread over the world and folk need to access the data from across the globe. That's already built in. Finally, I'll round up on this page. Every solution we build with Gen AI has safety filters. So we'll check for inappropriate content. We'll check for violence. We'll check for cussing, swear words, and things like that, essentially. We'll check for racial content. So when you use these solutions, you can be confident that Google has built into the actual underlying solution all of these checks ahead of time. And finally, as you start to generate content, you might generate an email or generate content for your website, you want to be sure that we're not just plagiarizing someone else. We'll actually build in the citation checks. I mean, I tell my kids, because everyone likes to use Gen AI now, like, you know what? You use somebody else, your homework might come back and you essentially plagiarized everyone on the internet. Google will actually build in the citation checks so that, first of all, we'll ensure that our models are not replicating information that someone else has written. And when we do have to use, essentially, text that someone else has written, we'll provide you a reference, a citation, so you know exactly where that's coming from. We won't act as though we wrote it, and then you use it for your purposes, and then find out that you just plagiarized sometimes. Okay, with that, I will round up by saying that we started off with a high-level overview of how we can help build your AI strategy and what Google's goal is there. We moved on to more traditional AI and saw speech to text and text to speech. And then we moved on to AI solutions like CCAI, Contact Center AI, Document AI, and then we ended up with our generative AI capabilities and Google's responsible AI. So I'll stop at this point. I know I'm way over. I'm sorry, everyone, but any questions anyone has, I'll take them now. I'll take any feedback. Thank you.
Thank you. Overwhelmed a little bit? Excited? Maybe both. Why don't we take a 10-minute break, get you moving, and then I'll give it time then to set up. If you have any questions, we're around. We're happy to help. Hopefully this was very helpful. Tons of ideas generating in your head. Thank you. We'll be back in 10 minutes, 3 after the hour. Yeah, I'll share everything. Yes, there's someone else. So we're going to get uber nerdy on this section. We're going to talk about data and analytics and all the cool things that Google does in this space. And And I don't know if people know this, but Google's mission is to organize the world's data. So we know data really, really well. We know all the cool things we need to do to make it useful. And today, Hannah's going to talk about the cool, what tools we have to help you do that. And some of the cool, and how we are using AI in the process as well to make that for you a little bit easier. When he is done, it'll be time to go. I'll have my Caresoft team come up and they'll tell you how you can set up a Google Cloud environment for yourself and all the cool things so you can do it securely and all that stuff. So we'll talk about that. So, Daniel, you ready?
Yes.
Excellent.
All right, thanks, Paul. Okay, thanks for staying here. It's a very long day for you. We've got down to the last session here, so we'll see the best for last. All right, so there's quite a bit of the AI talk here, and it's a very, very hot topic here. So there's not enough about AI we can hear. So we have two options next time. So we can invite Tony to come back to have a whole AI workshop day to learn more about AI. Or we can just forget about this. I'm just going to tell you a few AI jokes. Which one do you prefer?
The latter.
Tony? Tony is absolutely, so I'll forget my jokes here. So, but now let's talk about something serious here. Let's talk about data analytics here. Anybody has managed data, a database here? Quite a few, almost half of the folks here are doing data analytics here. So what we can talk about here in the next maybe 45 minutes to an hour is, and a couple of things here. I give you an overview of Google's data analytic platform. And then kind of talk about the approaches. When we talk about one specific technology for BigQuery, this is the platform that we can ingest petabytes of data. It's the same platform that YouTube's, Google Maps, Google Searches sits on, and can do real-time analytics and reporting. And we're talking about how do you manage both the structured data and unstructured data. And then I'm going to talk a little bit about AI. Of course, we can never talk about anything without AI, but how AI is working with in terms of data analytics. And then I'll give you a very quick use cases. There are many use cases, but I think Steve really talked about the things that we did for Hawaii. I'll give you one interesting use case that we actually built a very nice portal for climate change impact infrastructure. Actually, I'm going to demo that. The back engine is using the Google's BigQuery data analytic platform. All right, so here's the agenda for the next hour. And hopefully by the end of the session, you guys all become data experts in Google Cloud. In theory only. We'll come back with hands-on stuff. All right? So let's talk about a little bit about data challenges here. Of course, data is everything we're talking about here today, right? We are pretty good at managing what we call the relational database, right? Anybody have managed a database, SQL Server, Oracle, Postgres, MySQL, Sybase, right? Anybody have managed some of this what we call unstructured data, a database? Not much, right? So we are pretty good at managing our relational database, right? So for the relational database that we manage, probably close to 50% of the data we actually do in data analytics. Of course, for the unstructured data, video data, documentations, voice, and all that, that is actually the majority of the data that's sitting on today. But we're not very good at analyzing those, right? But today we need to analyze both, especially for unstructured data, right? Anybody know like how much data we're managing today? The whole world, the planet? Close to? Probably about 130 zettabytes of data. Anybody have some ideas of like what zettabytes is? How many zeros? When next time I took Korea a few decades back, I just learned how to spell gigabyte. Terabytes is a new term for me, right? But I just want to put it into perspective here for everyone. So I built this chart. Right, so we all know what kilobyte is. Megabyte, gigabyte, terabyte, if you manage database a few decades back, that's a brand new terminology, right? But we're into petabytes, of course, it's no big deal now, right? Exabytes, we are managing close, roughly about 130 zettabytes of data on the planet, right? And the majority of those are unstructured data. And then beyond that is yottabytes. I stop over there because I'm a Star Wars fan. That reminds me of Master Yoda, so that's why I stop there. It is actually 24 zeros that's in there, right? All right, but some of the data challenges I'm facing today, of course, legacy applications, there's quite a bit of those, right? Which is very hard to maintain. Anybody have gone through kind of like a mainframe modernization projects? That's really hard, right? Because one of the part I went to talking about mainframe modernization to Daniel, I have some good news and bad news for you. What's the bad news first? Well, the person that managed our legacy database just passed away. But the good news is that we find another person, but he's close to 80 years old. Right, but that's the things that we're talking about. Like some of the JS that we're talking about later is actually can go to the legacy system to extract mainframe code out of it and automatically rewrite them in modern language, so that can help with this, right? But the interaction, data style is a big thing, right? As we're talking about data analytics, it's sometimes data style is not just about the data is everywhere. There's all the redundancy. There's all the challenges that we're facing today, and of course. Real-time data becomes very important. Anybody still running ETL process for data warehousing? Of course, right? How long is a batch job is? A couple hours? Or depends on how big your data is. Sometimes it can run for a day or a couple of days, right? But we need real-time analytics. Anybody have using Google Maps this morning come to this place? Yeah. Imagine that if you're using delayed data sets. I'm not talking about a day. 30 minutes delay. Is this useful? No, right? We're talking about a platform that can deliver real-time data analytics. Of course, there's regulatory compliance, how do you protect those data, but also the skill sets, right? Especially talking about managed unstructured data, which is a challenge here. So when Google talking about data analytics, usually we're not talking about tool sets because there are tools that will have learned how data ingestions, how to maintain a database, and how to do data visualization. We're talking about a platform that will allow you to grow. I will tell you what I mean by that, right? So Google's approach, first of all, is that anybody have managed database in your lifetime? I'm talking about not unstructured, just a relational database, right? The typical performance tuning, security, high availability, patching, and all that. So, of course, one of the things, first thing I want to do is take the low-hanging fruit. So, as we move to a more of a cloud environment database, then the monitoring, the typical patch upgrade and all that, you don't have to take care of those, right? So you can only focus on the insight, analytical side of it, without worrying about the database itself, the redundancy and all that. Now, typical enterprise challenges when we're talking about data analytics, a couple of things here, right? One is, of course, we kind of talk about the data silos, all the breakdown of the data, right? Real-time data, how do you get real-time data, just like in Google Maps, the traffics are getting, right? Of course, we are only good at analyzing historical data, right? But how do you use the data to do predictions for the future? Right? That becomes very important. That becomes the AI component that comes in, allow you to do model predictions for the future. So in a nutshell, when we're talking about the Google data analytics, we're talking about really one is from a cloud perspective, right? The cloud data warehouse that you don't have to worry about scalability, performance, and all that, ability to allow you to ingest petabytes of data in real time, right? And then doing real-time stream of data, but of course, embed AI capabilities not outside of the database, but how do you bring AI into your database so you can write SQL statement that with AI model within it to make your life easier. Right? So as we talk about a complete life cycle of data management, right? We're usually talking about data ingestions, data cleansing, transformations, right? And then things that get into what we call the central repository, data mart, data warehouse, whatever we talk about this, right? And then, of course, on the data visualization side, you have a set of tools that can use to do data analytics. without getting into all the detail on those services, Google can deliver all that for you, but we are also open source. We're very vendor friendly. So if you're already using, let's say, Tableau or other tools, we can integrate those very well. Just kind of like Jeff was talking about earlier, right? Even the workspace ecosystem is integrated very well with the Microsoft system here. Now, but let's talk about right in the middle, which is the cloud data warehouse. I'm going to talk a little bit about the BigQuery part of it. So, a couple of foundations that we're talking about from data warehouse, right? In the 90s, a few decades back, we're talking about data warehouse, right? It's just bringing multiple data sets into a central repository. And then, of course, we're building some of those BI model foundations, right? So that we can do cube dimensions, aggregations on top of that. Of course, the trend now is moving to the cloud so that we don't have to worry about performance, security, and all that thing. But the next wave is really AI, using AI capabilities on top of the database we're talking about here. Right. So what BigQuery is in a nutshell, the central data warehouse that Google provides. It's a relational database. It's a self-managed service, and that's so you don't have to worry about installation and all that. That's pretty simple. You can stand up a BigQuery data warehouse in a second, literally, and you can start using it. But it can't handle petabytes of data because this is the same platform that the Google YouTubes, right? Steve talking about some of the references on amount of information we ingest, right? So this is the same Google ecosystem that we can handle petabytes of data that's in there. And then, as long as you know how to use a SQL statement, standard SQL, it works on that. It has all the data encryption, security, high availability. You can have multiple redundancy. You don't have to worry about failover, stand up a cluster, stand up a failover database. We're taking care of all that, right? And the most importantly is that the resource is unlimited, right? A traditional database or data warehouse, you always have to worry about number of CPU, memory, how do you have a balanced architecture, the network, the sense storage, the reconfigurations and all that. We don't have to handle all that, right? So we're taking care of that for you. But the question is that within the database, I'll get into a bit technical. This is probably the most technical slide I'm going to go in my whole presentation here. The BigQuery, the database architecture, the way how we do that is that we separate the server that runs the database engine code, the CPU, the memory, the VM, away from the storage side. What does that mean is that when you think about the traditional database server, right? You have set up a cluster database or a standalone database. You maybe have lots of CPU that's in there, right? 20, 30, 100. You have lots of memory, right? And then your sense storage is usually very close to your database server, right? Sometimes we do have those bottlenecks because how many HBA connectors you can put in from your database server to the sense storage, right? Each HBA device is probably cost you like $3,000, right? Most people I see they put like 2 or 4 max, right? But the bandwidth right now, we're talking about petabytes of data, doing data warehouse. Sometimes index is not going to help. You can do a lot of full table scan, you can do Cartesian joins for lots of data, petabytes of data. So there's a lot of I/O, the bottleneck in the network between the database server to the storage server. So we separate them out a couple of reasons here. One is that depends on the type of query you're running. Some of those are more I/O intensive, right? So we can scale up the storage server unlimited infinitely, right? Independently from the database server. And then we can also, if this is a more of a AI-driven query that using a lot of CPU and memory, then you can scale up the database server independently. But then you kind of worry about, hey, what happens between the database server and the storage server? All those pipelines have to push lots of data over between the two. We have those, we call it the petabit network in between. Those are Google's private fibers that we connect inside of Google's data center, across different data centers with the region, and also across the globe. One of the differences that the network is that Google does not rely on public internet. We try to push our endpoints as close as to your site. Imagine that, actually Google is responsible for almost like 40% of the whole world internet traffic. So rely on public traffic is going to be very difficult, right? Think about not everybody's uploading, downloading YouTube, looking at the Google Map traffics, right? So we have to rely on our own private fibers to connect. That stays not only between data center to data center, but also within the data center from the storage server to the database server, have very fast connections from database server to the storage server. This is how you handle large query, but not from just I perspective, but also from network, from storage output perspective, right? So any question on this one if I move on? All good. And the other thing becomes very useful is that Steve kind of mentioned earlier in the keynote here that Google is the, if I can characterize Google as a company, of course, because Google is a search company, Google is a YouTube map, advertising, whatever. But if I want to summarize Google is really, there are two identities. One is we are an AI company, the other we are a data company. We provide a lot of data. Our mission statement is really organize world's information and make it useful and accessible to everyone, right? So from a data warehouse perspective, we provide 200 plus of what we call it the public data sets. One example of this, like anybody during COVID had, not now, but in the beginning of the COVID, anybody had to look at the Johns Hopkins data sets? Quite a bit, right? How many cases or whatever. So we provide public data sets. It's all free to our customers. You only have to pay for the storage for that. That's including things like, from healthcare to equity in data, for economic data activities, to climate, to transportation. We provide a whole set of data, which can be very, very helpful in terms of when you do a data warehouse. A lot of times our customers have our own data sets in there, but they also ingest quite a bit of our Google's public data sets, to enrich data sets, to really tell a story about their use cases. And then another characteristic of BigQuery is that you can actually introduce AI machine learning capability inside a database. Traditionally, when you do AI, you have to take the data outside of database, right? Which is that, well, there's a lot of data when you do AI machine learning training models. You have to have really two areas to do things. One is my data warehouse, and then I will do AI. I have to take my data out maybe into an area. I'm using my Juniper notebooks to do AI analysis, and then I have to put in those data back into my data warehouse, right? So on the Google platform in BigQuery, you can actually, using standard SQL statement, to create a model and do model predictions and run analytics, all in the same time in one shot, right? So here is just a quick demo on this one, right? I'm using SQL statement to do a create model, right? Standard, I can create a prediction model that's in there. And the next thing is once I create a model, run a model, feeding my data, I do all my predictions, still using SQL statement. And then I can export my data, do my data visualization without actually leaving outside to the data warehouse. You do everything inside. Another feature, of course, is very important is that embedded GIS data that's into it. Anybody have managed a kind of GIS workspatial data, right? Because it is important, right? Just like I'm talking about Google Maps, a lot of those analytics, we are a very visual person, right? We look at the map to understand traffic, understand demographic, to understand where public resources are, right? Where's my school, a DME, go to restaurant, understand the ratings and all that. So we're using maps all the time. But all those analytics, you can do some of those inside of BigQuery. Right? That's another thing here. And then kind of switch gear a little bit, just talk briefly about the unstructured data. Anybody have managed unstructured data? Hadoop? I don't see a lot, even though I'm in the database business for a very, very long time. Managing unstructured data usually is quite painful, right? And the trend is that There are multiple technology on the market, but it seems like Hadoop, Spark is really taking that whole trend of managing, right? Starting with Google and Yahoo, all the company that does that. But installing Hadoop and the whole architecture, managing this on-prem is very, very challenging, right? So without getting into the details, that we package in that whole unstructured database into a service, so that you don't have to worry about that whole package all those unstructured database together. So net is that we created a very simplified Hadoop management system. It's called DataProp, and it can just stand up the cluster server and you can start just using it. It's just as simple as that, right? And then, of course, another thing I'll talk about is in terms of data stream, right? If you look at this whole ecosystem here, this is a typical smart data analytic platform, from data ingestions to data transformation to data governance to data processing to data visualization, right? And when you look at this chart, how many products you are familiar with? Probably quite a few if you're in data warehouse, data management business, right? Anybody have their favorite tool? I heard silence, so it sounds like Google platform is your favorite platform. My favorite tool used to be, anybody knows a tool called Cognos? They're now bought by IBM. Yeah, in early days, and when Cognos come over, I was actually working at ADP Dealer Service at the time. We give them one of the worst query you can have. And they have a very cute status bar. As you run a query, there's a little fish that's swimming on one end to the other end. So when Cognos come over to the demo, we give them the worst nasty query that they can imagine. They run the query, and the fish swim very slowly from one end to the other end. 20 minutes later, it goes to the other end. Everybody says, "Hooray, the query's done." All of a sudden, the fish turn around and swim the other way. and going backwards for a couple of trips. Yeah. So those are quite a bit of those tools, right? Informatics and a lot of those things here. But we can simplify the platform for you. This is what I'm talking about, a platform that using a few services we can handle, from data ingestions to data transformation to data analytics. But it is not limited to using Google services. If you have, as I mentioned, Power BI, Tableaus, and if you just may say, well, BigQuery, it sounds great, I want to mix use of those, it's totally okay. We have a lot of customer kind of mix match with those technology. That's what I'm talking about. We want to provide just a platform they can use. Right? And then this is a more busy architecture that's in there, which has more detailed services that's in there. Without, this is only like a less than hour high-level presentation. As I mentioned earlier, we're happy to come back to some deep dives, on data analytics, on AI, right? For those maybe a whole day workshop. But I'll point out a few things here. From a data collection perspective, we have a service called PubSub. Think about PubSub as really like publishing and subscribing, right? If you have multiple data sources, whether it's from YouTube, from emails, from different legacy mainframe system, this is a kind of like a temporary holding all those petabytes of data ingestion that's in there. You don't have to use that, but it's a place you can kind of like redirect all the traffics. Think about this. All the data traffic that comes in, I'm using PubSub to hold this data, but I can then redirect them into the data warehouse. So that's the way how it works, right? And then in data processing part of it, we have a data flow that's a process that can do both a batch ETL process, but it also can do real-time data stream. Real-time data stream for petabytes of data that's in there. So that's called data flow. And there's an equivalent service called Data Fusion, which is, think about this about a GUI version of the same thing that you can kind of just like drop map, here's my data source, here's the map, here's the transformation, that I can just do that, right? And then from a data transformation perspective, we also have a couple of services like data prep, data composer. All that does is they can do those data mappings to allow you to transform some of the raw data sets into some of those ready to report kind of reporting tables, and then you can go from there. And then in between, there's a lake of data types. This is really the way how you're thinking about data governance to kind of like a central command, because a lot of times I need to understand where my data is, understand my metadata, right? Metadata management becomes very important as I ingest new data sources, understand a lot of those actually using some of those AI technology to kind of do some of the data mapping, discover data for you. So there's also the equivalent of data catalogs. The name itself sounds like just like doing data catalog to understand the metadata for itself, right? Of course, in that middle of that piece is the BigQuery, right? Which is, of course, has AI machine learning capability within those, but it also can scale really high, right? And then the data you collect, if you really want to do some of those discovery, we can, using still any of the data visualization tool that you have, Google can provide you things like Looker. Those are data warehouse. Think about this kind of like the Microsoft, Power BI Tableau. We have Looker, so we can use this for data analytics. But we're also pretty open to quite a bit of the third-party ecosystem for any of those data visualization tools that you have. And then Tony kind of mentioned about earlier some of the Gen AI stuff we're talking about, right? With the Gen AI, you can pretty much look into your internal, let's say, website, but thinking about this is like doing a Google search for internal websites, but that is not limited to a set of drives, the documents, the websites internally you have, but we can also have the capability to connect to the database itself by using natural language, have a conversation, right, without actually understanding the SQL statement. Right? So this is really the whole portfolio on the very high level, depends on what your role is, whether you're a data engineer, a machine learning expert, or it's just the end business user or consumer side of it. Right? So, any questions so far? All simple, easy, right? All right? That's really hard. Like almost 3 o'clock in the afternoon, you guys are still sharp, understand everything. You're the best group here. Right. So let's talk about some of the machine learning capability a little bit here, right? I think Tony talked quite a bit of those, so I'm not going to spend too much time on this one. But this is kind of think about this is the Google end-to-end AI platform, right? You can, using BigQuery, to do some of those AI machine learning capability inside of database, but we can also do this outside of database. But what we deliver is a platform from infrastructure all the way to all the models that we provide, the things that Tony talking about, the CC AI, the document AI, vision AI, context AI. I'll give you a few of those examples here. I will show you an example that we did a Climate Insight project and the safety analytics. How do we turn some of those unstructured data become something that's visual, easy to understand relational data types, right? And of course, on the bottom, I'll also mention, anybody heard of TPU? I know what that is? CPU, of course. Yeah, and the GPU is a really hot form, a commodity today, right? Because everybody wanted AI machine learning, they want to using GPU. Actually, almost 10 years ago, one of the Google AI, the foundation person, he said one thing even back then, because that's when we managed all those Android phones, right? But we need to do some of the analytics stuff. So, well, if we just record 3 minutes of every person's voice, 3 minutes to analyze those, we basically can do what? Exhaust every single CPU on the planet. But imagine, I'm talking about today, we are looking at, remember the chart I gave you the number of zeros. We're collecting what, 130 zettabytes of data, right? That's like 18 zeros, right? So that's quite a bit of data. But to process all those data require a lot of CPU, which is not enough CPU on the market, right? Even GPU there. So Google invent our own. We're actually a hardware manufacturer too. We invent our own infrastructure CPU that's in there. So TPU is we made specifically to process TensorFlow. That's underneath is Google's transformers and Google's own AI model. So we actually invented TPU specifically to process AI-specific workload because it requires lots and lots of data. When we invent initially the TPU way back, it's about 20 to 30 times faster than the fastest chips on the market from a CPU perspective. That's how fast it is. That's how you can analyze all those, right? And of course, on top of that, you have all different of those pre-built models. But then again, you can also train it on your own models by feeding. You have a base model that Google provides, and then on top of that, you can add into your own data sets to train the model to make it look better for your own data sets. So here is just one of the examples. This is actually a safety analytic platform that we're building for state of Hawaii, looking at Vision Zero, looking at some of the intersection, doing crash analysis from a traffic perspective, right? So this is actually in downtown Honolulu that University of Hawaii have a bunch of cameras that in that intersection from downtown Honolulu all the way to the airports. So as traffic goes through it, all the vehicle speed directions, was analyzed. You can also analyze pedestrians and all that. Same thing with, this is just a video clips. That's also in downtown Honolulu. You can see that one person that does the jaywalking. Actually in Honolulu, you get a big fine. So it just does all the safety analytics. But the end results from there is, this is what you see, right? By using, this is one of the examples by analyze vision data, right? And then turn into something that is more useful from a Department of Transportation perspective to analyze traffic patterns, right? In certain intersections, you can do crash analysis and all that. Understand the bike, roadways and all that. So with that, I'm going to just do a quick demo on the safety, on the Climate Insight project we did. So before I go into the demo, this platform is built on top of the BigQuery data analytic environment. And this is a really high level on what the architecture will look like. So at the very bottom, DOT itself, they provide initially about maybe 120 different data sets for us. But then that's not enough from a climate insight perspective, right? Because they want to understand is that, well, climate change, sea level rise, 20% of the roadway is actually in Hawaii built on the coastline. With sea level rise, road erosion happens quite often. Before, maybe every 10 years, every 5 years, they have to fix certain spots on the roads. But then that frequency happens more often, right? If we're looking at in the future, a few decades later, with sea level rise, maybe some of those roads will no longer exist, right? What happens to the community that lives over there? Who lives over there? What is the economic impact on all those? There's all those things, right? Because when we started the project last year, that was go live a few months later, the top concern is more about like the sea level rise, the lava flow. Actually, the Governor Green, as you mentioned, when he was a young doctor, was on the Big Island when the volcano evoked, blocked certain roads. It is very hard for him as a young doctor to get critical medical resources, right, to help the local communities from, the island of Oahu, which is most of the resource that come in. But in California or Nevada, it's so dry, we may worry about wildfire, but nobody would have thought about that, the Maui fire that happens 2 months ago, right? Which, if you think about Hawaii, it's all like palm tree, beach, lots of water, this is not a place that you're going to have Wi-Fi with Earth combined, but a lot of things the platform established is really looking at prediction for the future. So the idea which is really we ingest the DOT data sets first, and then as I mentioned about the BigQuery platform has 200 plus public data sets, including a lot of economic data sets, equity data, understand who lives in there, public resources, all become important because from a climate project perspective, even though it looks at impact from how weather change, climate change has impact on infrastructure, roads, but at the end of the day, it's really about people living in those areas, right? So we have to understand the demographic, economic activities and all that. So we brought in quite a bit of those data, and plus Google Earth Engine data, Maps data, Waze data that's in there. But we also have a very large third platform ecosystem that we will be able to bring additional data sets, things like traffic data, stuff like that. And then the reason I said this is a platform, this is not just two sets, because you can gradually bring this data two sets into this ecosystem, right? You can break that kind of data silo. We understand that day one, you may not be able to get all the data sets you need, right? But so you can build one use case at a time. So at the very top, right? So it's really the certain use case you want to build, and then you can use AI model prediction to do some of those analytics. So with that, I will end my presentation with a quick demo on the Hawaii platform. There's two platforms I'm going to show you is the Climate Insight, which is building on this BigQuery data platform. Right? Any questions before I go to the demo? All good? All right. So this is actually a public web portal. I can show you where the web portal is so that you can all go there up there with yourself. We built two of those. One, this is a public one, everybody can use it. We also built a more sophisticated one just for internal users for DOT, where they can do more analysis, things you mentioned about earlier that, let's see, in the North Shore, if the road gets blocked for whatever reason, whether Wi-Fi or sea level rise, how do you redirect traffic? How does it impact on the community around it? Right? So things for Hawaii is like nothing. They are concerned from climate perspective, right? Tsunami, lava flow, right? Wildfire, which sea level rise, erosions, right? And all those things we're looking at. So if I go to the platform, this is more of a kind of like a geospatial driven platform, so you can visually see this. My internet is a little bit slow, so things may pop out a little bit slowly here. But anyway, anybody been to Hawaii? Vegas is pretty close to the island, so it's a popular. In Hawaii, what's the most visited destinations for people living in Hawaii? Vegas, exactly. That's their favorite place. So there's a lot of direct flights that come over here. So this is the island over here, right? So if I go to this platform here, if I click inside over here, this is real-time data driven from BigQuery, petabytes of data that's coming. But it will show you like the project status, pavement, bridges, all that within all those islands. As I'm moving into, let's say, the island of Oahu, which the majority, 90% of the population lives, right? So on the left side, the dashboard will real time, depends on area and focus, will give you reports on that one. But then you look at all those very busy green dots over here. That's really all the DOT assets from the state, right? From major projects, sidewalks, annual flooding zone, traffics, truck routes, right? Bridges, tunnels, DOT assets, key projects, a lot of information. So you can continually ingest into this platform for all those information that's in there. It's a little bit busy, so what I'm going to do is I'm going to unhighlight all those things, so the map is really clear right now with nothing that's in there, right? So now I'm going to be, let's say, focused on bridges and tunnels only, right? So then on the map you can see, only those bridges and tunnels that are displayed on the maps. But now, like from climate insight perspective, if I want to understand maybe sea level rise, erosion impact on some of those road infrastructure here, right? So here's my hazard, right, index over here, from landslides to sea level rise to annual flooding zone, erosions. I'll just pick a few of those here. Coastline erosions. Now, as you can see, it may not be very clear on those areas, so I might highlight those, right? The area that's showing the flooding zone, this is where sea level rise and how it correlates to the infrastructure side of it, right? So this is how things that can relate to it. Anybody have watching a surfing at North Shore? With a high wave, they can go really, really high. But this is also where the sea level rise and the sea erosion happens, right? So this is one thing to look at. But then other things I can also look at is, as I mentioned earlier, we look at the climate infrastructure impact, but at the end of the day is really talking about people, right? So I can look at equity index to look at, from a demographic perspective, right? Those polygons are, the hexagon polygons like in a size of 200 meters in square, you can change those. But even as end users, I can go there to adjust those index here, right? So that I can kind of make sense out of it. And I can also, looking at, from an economic status perspective, look at where all the economic activities happens in all those areas on island, right? What are some of the critical facilities from an ecology perspective? So there are many things you can look at. And then as more data it collects, you can really tell more story on this. When I can look at from a population perspective, I look at where Native Hawaiian lives. So this platform can keep building on top of this. They can be different things, right? Can solve for, let's say, homeless issues, can solve for many different things as a state or as a government agency trying to understand, where my resources are, hospitals, schools are, how it relates to, the people that lives in those areas. So this is the platform as I go back to on the technology side, right? It's building a very simple BigQuery platform, ingest with customers' data sets, Google's public data sets, and then if we need it, we also have a large third-party ecosystem can ingest additional data sets, and then using powerful visualization tool really to tell a story for those use cases. So that kind of ends with my presentation here. So kind of in summary, we're talking about what is Google's smart data analytic platform, right? So our approach, as I mentioned earlier, is that we don't want to just give a bunch of tool sets, right? Because you saw there's one chart I have, list all the tool sets from ingestion to data visualization for this whole life cycle, and those tools keep changing, right? So we want to give you a platform that's consistent, you can keep building on top of that, and then that allow you to manage both the structured data you're good at, but also manage unstructured data, right? One of the examples I give you is that taking video clip data that turn this into more of a structured data, you can tell a story, right, in a relational format. That platform will have, all the nuances that's in there, from data governance to data protections to data transformations. But most importantly, from a data ingestion perspective, you can handle petabytes of data in real time, right? My analogy is that, just like Google traffics, right? You cannot have traffic that's even 15 minutes delay. That's not going to help me to get from point A to point B, right? And then we have lots of public data sets that allow you to enrich your data sets. That's very important because, they can really give you a whole story because data really tell the story, right? And then, of course, AI is a very important part. As I mentioned about, the ecosystem, that a cloud data warehouse that's easy to manage, lots of data in real time ingestion data, but the trend in the future is really to bring AI into the picture to do predictions for the future, right? But not only to the data outside the database for analytics, for AI machine learning capabilities, but we actually brought AI into a database to make your life a little bit easier. So that's really the Google's analytic platform in a nutshell. Thanks for your time.
Okay, let's wrap. I wanted to have Nate and Leah, if you guys can come up. I know they were helping with the registration. You probably got some emails from them. There are teammates from CareSoft, and they have a very tight integration with Google. They help us manage all the minutiae that Google are not good at, which is all the legal stuff tied to contracts and how to make sure everything's up. Nate, if you don't mind introducing yourselves, and that'd be awesome.
Absolutely, yeah. So Nate.